So now what I want to look at is I want to look at this example, 65 divided by 9, right? So let's do that over here. We ask ourselves, what is 65 divided by 9, right? What is the first thing that we're going to think about? Well, we're going to start thinking about um, the multiples of 9. 9 times 1 is 9. 9 times 2 is 18. By the way, as I'm doing these, I want you to follow along with me um, so that you can help to remember your multiplication tables as well, right? So 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. 9 times 6 is 54. 9 times 7 is 63. 9 times 8 is 72. So it must be 9 times 7, right? 9 times 7 is 63. So there we go. Yes. So let's write that down here. 9 times 7 is equal to 63. We know that 9 times 8 is 72. So this multiple is too large. This is the right multiple, the 7. Okay? Okay. What's the next thing we have to do? To find the remainder, we have to find out by how much does the number we're dividing, the 65, by how much does it exceed the biggest multiple of 9 that does not exceed or equal it, right? In this case, the 63. So 65 minus 63, you can see here, 5 minus 3 is 2, 6 minus 6 is 0, so we just leave that blank, and we can put remainder 2. Okay? So that's our result. Okay. And by the way, this is one of the main reasons why it's best to know your multiplication tables by heart, um, so that you can do division problems. Okay. Now, of course, we're going to see later where we're going to do division problems where you don't have to have those multiplication tables memorized, where we're going to construct it on the spot. But with single digit numbers like this, it's best to have your multiplication tables memorized. Okay. By the way, in case you want to memorize your multiplication tables, use flashcards and focus on one particular number a day. Okay, today I'm going to focus on sevens. I'm going to quiz myself and I'm going to master them. Maybe I'm going to count by 7 until I can count by sevens automatically, right? Spread that out over maybe 60 days. One number today, maybe in 2 days, another number. Um, and over the next 60 days or so, you will memorize your multiplication tables. Okay? Okay. Anyway, so this is the result, right? What does this mean? I always want you to keep this in mind. Whenever you have your division result, what does this mean? This means that 65 is equal to 7 times 9 plus 2, right? The 65 is going to be equal to 7 times 9 plus the 2, okay? Okay. So now, before we proceed, so now what I want to do is I want us to again look at the long division notation. How would we do this with the long division notation? So we want to do 65 divided by 9, right? So what we do is we place the 9, which is the number we're dividing by, outside of the division house. And we place the 65, which is the number we're dividing, inside the division house. We ask the question, does 9 go into 6? Of course not in this case, right? The 6 is smaller than 9. Does 9 go into 65? Aha, it must, right? And in our brain, we think of our multiplication table, right? Let me write it down here just for our enjoyment, right? So of course, if my n is 1, 9 times 1 will be 9. If my n is 2, 9 times 2 is 18. One of the things I want you to notice about this table is I can generate the next multiple by just adding 9 each time. So 9 times 3 is the same thing as 18 plus 9, which is 27. 9 times 4 is going to be this plus 9, 36, and so on. 45, 54. Okay. And you can see that if I ask how many times does 9 go into 65, and look at my table, it goes in 7 times. Because if I go one more down to 8, I'm exceeding the 65. Right? So then 9 goes into 65 7 times. 7 times 9, as we see in our table, is 63. And then here we perform our subtraction. 5 minus 3 is 2. 6 minus 6 is 0, so we don't write anything. Once we've done that, that is our remainder. Okay? By the way, I wanted to show you this here so you can see how you can generate a multiplication table on the spot by just adding each time. Okay? Right? Okay. I hope you've enjoyed this example, and I hope to see you again. I hope to see you again. Thank you.